It weighs about 5,000 pounds. It pulls between 225 and 245 kilowatts, roughly what 200 American homes draw on a hot afternoon. AMD rolled it onto a stage in San Francisco on the 23rd of July, 2026, and the pitch was straightforward. If you want to train a frontier model, you finally have somewhere else to shop. The cabinet is called Helios. 72 Instinct MI455X, accelerators and 18 6th generation EPYC, Venice CPUs, liquid-cooled, wired so the software sees one computer instead of 72. The processor at the center carries 320 billion transistors on compute dies built with Taiwan Semiconductor's 2-nanometer process, and it is the largest chip anyone has pushed through that company's advanced packaging line. Each accelerator holds 432 gigabytes of high bandwidth memory, 50% more than anything NVIDIA sells today. Fill a rack and you get 31 terabytes in one cabinet, against roughly 20.7 in NVIDIA's competing system. 31 terabytes is the number worth keeping. A trillion parameter model fits inside one rack instead of getting sliced across several, and when a model is split up, the pieces spend real time talking to each other over the network. That time shows up as latency, and latency shows up on the invoice. The specs are not why anyone is nervous. On the 22nd of July, Anthropic committed to deploying up to 2 gigawatts of these processors, with the first gigawatt starting in the first half of 2027, and AMD committed in the same announcement to a strategic equity investment of up to $5 billion in Anthropic. Tom Brown, Anthropic's co-founder and chief compute officer, put it plainly: running across a diversified range of hardware lets you map the right workloads to the right machine. Anthropic is not the only one. OpenAI and Meta have separately committed to 12 gigawatts between them. Microsoft is bringing Helios onto Azure. Oracle is on the list, and so is Cerebras. 2 gigawatts is not a purchase order. It is a claim on a region's electrical grid booked years ahead by a company that was not seriously part of this conversation 18 months ago. Which is the part I keep getting stuck on, because AMD nearly did not survive to have this decade. In 2014, after Bulldozer landed badly, the stock traded like a penny stock, and the company had been written off as a permanent runner-up. Lisa Su took the top job, killed the low-margin projects, and bet everything on a modular chiplet architecture called Zen. 3 years later, Ryzen and EPYC shipped, and the assumption that Intel owned the server room quietly stopped being true. Nobody announced that. It just stopped. The accounts now read like this: first quarter of 2026, revenue of $10.3 billion, up 38% year over year. Data center alone brought in $5.8 billion, up 57%. 2 years earlier, that segment was about 38% of the company. Today, it is 59%. Free cash flow hit $2.5 billion for the quarter, a record. Su called it a clear inflection and a structural shift, and for once the corporate language was doing less work than the numbers underneath it. Then you set it next to NVIDIA, and the mood changes. NVIDIA's data center business booked $215.9 billion in fiscal 2026. AMD's entire company booked $34.6 billion in fiscal 2025. By one widely cited estimate, NVIDIA holds upward of 95% of the data center graphics market against AMD's 4.5%. Every good number above belongs to a company still climbing out of a very deep hole. The moat was never the silicon anyway, it was the software. For nearly 20 years, every researcher who learned to program a GPU learned to do it in NVIDIA's language, and that habit compounds in a way transistor counts do not. AMD's answer this year is a platform called rocm.ai, and buried in it is a detail I had to read twice. AMD is using Claude, Anthropic's model, to write and optimize the software that will run on the hardware Anthropic is buying. The company says the system is continuously tuning around 14,000 models, and a live demo pulled 38% more throughput out of one of them with nobody supervising it. So the chips are being tuned by the model that will eventually run on the chips. I don't have a tidy read on whether that is impressive or slightly unnerving. Probably both. Either way, it happened in public this week. Some caution is earned here. Back in February, the analyst firm Semi-Analysis reported that manufacturing problems would push real mass production into the second quarter of 2027, which would leave 2026 delivering engineering samples and low volumes. AMD's vice president of artificial intelligence software rejected that in the bluntest terms a public platform allows, said the schedule was intact, and added that speed is the moat. One of them is wrong. Racks on data center floors will settle it, not press releases. There is a second uncomfortable number. Analysts at Futurum estimate a Helios rack costs roughly 40% more than NVIDIA's competing system, which inverts this company's entire history. AMD is not the cheap option anymore. It is charging a premium and arguing that the memory and the token economics justify it. Meanwhile, the stock has traded around 92 times trailing earnings, roughly double NVIDIA's multiple, and Morgan Stanley has sat at neutral the whole way through. William Blair initiated coverage at Market Perform while projecting revenue would nearly double to more than $104 billion by 2028. That is what caution looks like when the fundamentals are good and the price already assumes them. AMD's own performance claims deserve the scrutiny. AMD is asking NVIDIA to accept. The headline, 30% more tokens per dollar, comes from AMD's labs, measured against NVIDIA's published numbers rather than an independent test. The two companies do not even use the same 4-bit number format, so the arithmetic being compared is not identical arithmetic. To AMD's credit, its engineers volunteered that the new processor sustains roughly half its theoretical peak in real measurement, which is the kind of thing most vendors bury in a footnote and hope nobody reads. NVIDIA still holds real ground. Its host connection between processor and accelerator runs at 1.8 terabytes per second against AMD's 256 gigabytes. Its data processing unit moves twice the traffic. And for an ordinary enterprise developer who just wants something that works out of the box, NVIDIA's software is still much easier. Helios was not built for that developer. It was built for the handful of labs with enough engineers on staff to fix whatever breaks at 3 in the morning. None of which touches the constraint neither company controls. Gartner expects worldwide data center power demand to rise 27% this year to 132 gigawatts and to reach 290 gigawatts by 2030, with a blunt warning that grid supply will not be sufficient. In the first months of 2026, more than 75 data center projects worth $130 billion were blocked over power and water. In one Virginia county, officials asked their own employees to conserve electricity because data center demand was pushing utility rates up. Building the fastest chip stopped being the hard part a while ago. Finding somewhere to plug it in is. The openness is the piece that matters most outside this industry. AMD built Helios on open standards throughout. An open rack format, an open interconnect running over ordinary Ethernet, standard merchant switch silicon from Broadcom, an open source network operating system, and published specifications any customer can download and rebuild to their own design. That is the opposite of a proprietary lock, and it is the part I would watch if I were NVIDIA. The roadmap keeps going too, with a next-generation accelerator in 2027, another in 2028, and server processors mapped out to 2030. You will never buy one of these cabinets. You will pay for them anyway, in the price of every service running on top of them and in the electricity bill of whatever county agrees to host them. Competition this far up the stack takes a few years to reach the rest of us, but it does reach us, usually as a price that stopped going up. So where do you land? Is this the moment the AI hardware monopoly actually cracked? Or is it an expensive second source that still has to prove it can ship at volume? Tell me in the comments. If you liked this video, don't forget to like and subscribe, and click the next video on your screen for another interesting breakdown on the latest technology. There's a lot more coming.